Okay, so an isosceles triangle is a triangle with at least two congruent sides. So anytime we talk about isosceles triangles, we have two sides that are equal to each other. We call those the legs. Okay, those are the legs. And then we have the base of an isosceles triangle. So the base is not connected to the other two sides that are equal to each other. So that's kind of what separates the base from the legs. And then the base angles are going to be the two angles that make up that bottom isosceles part of my triangle. And the beauty of it is that this angle is equal to this angle over here. So we have these two angles that are congruent, and it makes the sides opposite them equal as well. That's the beauty of what an isosceles triangle can do for you. Okay? Now, if we add a third equal side and angle onto that, which we're not going to do here, this is just isosceles, but if we were to do it here, now all three angles are 60 degrees, because that's the only way you can get it to equal 180. And then that means all three sides are equal. So we have an equilateral, equiangular triangle. And if the angles are equal, the sides are equal. And if the sides are equal, the angles are equal. That's all these two theorems are saying. They're literally just saying if you have one, you have the other. You can't have one without the other. Because if all three sides are equal, all three angles have to be equal. And what's 180 divided by 3? You guessed it, 60 degrees. Okay? All right. So, use these properties of an isosceles and equilateral triangles to find the indicated measure. Okay? So, I know this angle and this angle are equal to each other. Those are our base angles. So, x has to be 47. Okay? In that same case, here and here, these angles have to be the same. So this is 50 and 50. Now I know what you're thinking. Okay, well, this is 52. No, sorry, it's not. But we do know all the angles in a triangle add together to equal 180 degrees. Because that's the triangle sum theorem. And I'm not going to do this for all problems. I'm just going to do it for the first one. And then I know I can combine like terms. And I can subtract 100. And then what's left over? Just 80. So this is going to be 80. In that same idea, I know this angle's x, so I know this angle's x. So x plus 40 equals 180. Or that's 2x equals 140, or x equals 70. Now, what did we talk about in an equiangular, equilateral triangle? Every time these have to be 60 degrees. If you have an equilateral triangle, the sides can grow in length. Like this could be 3, 3, 3. You could change it so that they're 4, 4, 4, 5, 5, 5. You can change the side lengths and the numbers for the sides, but the one thing you cannot do is change the angle measures. The angle measures are always going to be 60, no matter what. Okay? So this one, I've got 68 plus x equals 180. Now, here's a new one. Because the angles are equal, that tells me that this side is equal to that side. So I know x is going to equal 8. I know this side is equal to that side is equal to that side. So all of these sides are 7 because all the angles are equal. And this side over here, and why do I know that? Because I'm going across those angles so that this side equals 12 as well. So I don't know. I might have gone through that a little quick, but try and catch on or rewatch that little section. It's not too bad. But let's set up some actual solving of a problem. So this one, I can see this side is equal to that side, which means this angle here is going to be equal to this angle here. So if this is x plus 22, this is x plus 22. So I'm going to do x plus 22 plus x plus 22 plus 70 equals 180. So we just took this angle plus this angle plus that angle, because that is the triangle sum theorem. Now we can combine like terms. So I see an x and an x, and then I see a 22, 22, and a 70. So we'll have 2x plus 90, 110, 114. 90 plus 22 plus 22, 114. Is that what we said? Okay. Equals 180. And we can call that combine like terms. And this happens with my students as well. I would start to adjust this. I would erase and rewrite this so that I can draw my line down the middle of the equal sign. Okay? I like that. I get in the habit of that a lot, and just something that I've always done to keep my brain organized. So that's the subtraction property of equality. We want to zero out the 114s. We're going to be left with 2x equals 70, 66. And then division property of equality. So we're going to divide. X equals 33. And that's all I wanted to do for this problem. If we plugged it back in, we could get 55, which is 110 plus 70 is 180. So just a little game, you can play with that. Next, play this game. We know this angle and this angle because these sides are congruent. So being able to go directly across to find the angles that they're talking about. So 4x plus 45. So both of these, take them and do 4x plus 45 plus 4x plus 45 plus 50 equals 180. Triangle sum theorem. Okay. Then combine our like terms. Combine, and then let's draw our line down the middle, equal sign, stay organized. 180. And 8x. And 50, 100, 140. And we'll subtract 140 from both sides. That's the subtraction property of equality. And then 8x equals 40 because we zero out the 140s. And then we are going to divide by 8 on both sides so that we get x equals 5. So that's division property of equality. And then we want to 1 out the 8s. All right, so we knew these two sides were equal to each other, so I know these two angles across from them are equal to each other, and then all three angles in a triangle add together to give you 180. Yo, what's good, Dad? Hey, what up, baby? What up, Sully? How's it doing? Hope you're doing well, getting ready for the week this week for you. So yeah, so x equals 5. You can plug it back in to find these two angles. Nice. Welcome back. Although, just got a blank spot for your name. Thank you. All right, so x equals 5. We can plug it back in and get 5 times 4 is 20 plus, so that's 65, 65 plus 50. throw those in. All right, number 6. Because all 3 of these angles are equal to each other, and you know that because they all have one arc. They all have one arc. So that means they're all equal. So that means that the side lengths are all equal to each other as well. So for this one, we're going to do 5x minus 12 equals 3x minus 4. Our justification is we can use the definition of an equilateral, or actually equiangular is probably going to be equiangular. So the definition of an equiangular triangle. So if I know all 3 angles are equal, I know all 3 sides are going to be equal. So I can set 2 of the sides equal to each other. And we can underline, draw a line down the middle of the equal sign. And now you can see that the highlights are on 2 different sides. So what that tells me is I need to move either 3x to the other side, or I can move the 5x to the other side. I'm going to do the 3x because I don't like negative x's. So that is subtraction property of equality. We are zeroing out the 3 x's. So then I'm going to add 12 to both sides. That's the addition property of equality. So that 2x equals 8. Divide by 2, and x equals 4. So we're going to do division property of equality. We are going to 1 out the 2's. This is division property of equality. This is zeroing out the 12's. Skipped a couple justifications. So x equals 4. 5 times 4 minus 12, so that's 20 minus 12, which is 8. So that would tell you all 3 sides are going to be equal to 8. Now, we could have put that in here. 3 times 4 is still 12, minus 4 still gives us that 8. So there's plenty of numbers that we can use, plug in, but make sure at the end of the day we find that all 3 sides equal 8. Okay, so here's going to be a bit. Whoa, what am I going to do here? Let me check this problem. Maybe I didn't put all of it down. I might have missed something. Find the value of x, then find the measure of the angle or side length. Okay. Definitely can't do that one. I bet that's why there was another one on top of it. I'm going to guess this is what it's supposed to be, and not here. So we're going to play that game. And that's the game I want to play with my students as well when we do this is, listen, this is the original problem, because what you will find out is that this angle is equal to that angle. So that means, well, this side across is going to be equal to that side across. So we can set up 4x plus 7 equals 6x minus 5. And opposite angles equals opposite sides. So opposite angles, opposite sides. So we can underline our variables, draw our line down the middle of the equal sign, and we can see the highlights are on two different sides. So once again, I'm going to subtract 4x from both sides. So subtraction, property of equality. That's going to leave me with 7 equals 2x minus 5. And the reason we did that is because we want to zero out the 4x's to get all the x's on one side by itself. Then we can add 5 to both sides. So that's the addition property of equality. And that's because we want to zero out the 5's this time. And that's going to leave us with 2x equals 12. Then divide by 2. And x is going to equal 6. So that's the division property of equality. And we're going to 1 out the 2's. Now, x equals 6, but it's looking for AB. And if AB is 4x plus 7, that's given. We're going to do 4 times 6 plus 7 equals AB. That's substitution. And then that's 24 plus 7, which would be 31. So AB equals 31. Multiply. And then you can put simplify or combine like terms. And you're good to go. Huh, good thing I did that so that I could figure that out for that problem. All right. Well, that takes care of this section. So